Okay, we're in the shop today. It's January 3rd, 2018, and part of my New Year's resolution was to try and get some more videos put out this year. I do lots of work here in the shop, and I fail to document it very well. I usually start out with good intentions, and it just takes so much extra time that I generally get halfway through and then I just abandon the documentation part. But today we're doing things a little differently. I didn't document anything up to this point, but I'm going to go back and kind of show you the beginning of the project and the prototype, and then we can see the finished product. So what the project was I had to do a custom oil pan for this bike motor. Here's the motor sitting upside down right now. This is the stock pickup, and it fit into the pickup. There's the stock oil pan. It's got a steel tray at the bottom that screws in, and then the screen fits in tight. There's a seal, a gasket at the bottom, and it forces the oil. There's one hole here that it can pick up oil, and then it forces it to pick it up into these little channels in the front. So in the stock motor, this oil pan sits level like this, and it's forced to pick the oil up from the front, and what it is if your oil level gets very, very critically low, it's always pulling oil from the lowest points in the pan. And so I needed to replicate that, but in my application I tilted the motor forward. So now the pickup wasn't in the lowest point of the pan anymore. And the other thing that happens when I did that was part of the oil is actually above the level of the pan into the cases of the engine. And when I tilted it forward like that, if I was to maintain that same oil level, it was going to put oil up into the crankshaft area, and I didn't want that. So my oil pan had to be able to carry a greater oil capacity. And then the third thing was on the stock bike, the exhaust actually ran outside of the oil pan quite a ways. And on my new design, I tucked the exhaust in almost under the oil pan. So I needed to notch the oil pan to clear the exhaust. So the first thing, I printed up a pickup extension. I used a 3D printer, and so that moved the pickup much deeper, by almost like 3 inches, and then it also gave it a 10-degree tilt, which is how much the motor was tilted. So it moved the pickup back to a horizontal position. Then I printed up, I 3D printed again a new flange, and I had designed the new oil pan on the computer, and printed out all the sheet metal parts, made them out of cardboard, and just made a cardboard and 3D printed prototype to check my fit. So that all fit, and my exhaust system fit up underneath here, so everything was good. That was a quick way to check everything. So then I used those same printouts as cardboard templates, and I replicated the oil pan in aluminum. So I milled a new flange, and then I cut and welded all the sheet metal parts, sheet aluminum parts, and put it all together. I made these all out of 0.10 wall aluminum, and I kind of wish maybe I had gone a little thinner. This thing's pretty heavy. It's almost twice as heavy as the stock one. Down inside you can see I kind of replicated the same concept for the oil pickup, rather than using a steel tray, I machined an aluminum pickup tray. So again, there's a baffle. All the pickup is down at the very bottom, and so again, if the oil level gets low or anything, you're always picking up that oil from the bottom of the pan. So there, that all fit. The last thing I have to do, I machined up a little cooling fin for the bottom, and that's going to be the last step, is I'm going to weld that onto the bottom of the oil pan for a little bit extra cooling.